Use the trapezoidal rule, the midpoint rule, and the Simpson's rule to approximate the given integral with the specified value of n, and then round your answers to 6 decimal places. For this one, we have the integral going from 0 to 1/2 of the function sine of x squared dx when n is equal to 4. So the first thing we want to do is we want to figure out what is delta x. Okay, so we know the following. We know that the lower bound is a, which is equal to 0. We know that the upper bound is b, which is equal to 1/2. And we know that n is equal to 4. Okay, and so for delta x, we know that that's equal to b minus a divided by n. So we know that b is 1/2 minus 0 divided by 4. And so 1/2 divided by 4 is 1/8. So therefore we have 1/8. Okay, so let's take a look at the increments for the 4 subintervals. Okay, so if we're going from 0, the next interval is 1/8. The next one is 2/8. The next one is 3/8. And the last one is 4/8, which is the same thing as 1/2. So therefore, there are our 4 intervals. So using the trapezoidal rule, let's go ahead and then take a look at the definition again. So it's delta x divided by 2 times f of x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2, and so on. Okay, all the way to the nth interval. So since we're finding 4 subintervals, that's going to equal delta x, which we know is 1/8. And then we're dividing that by 2 times f of the first lower bound, which is 0, plus 2 times f of the next interval, which is 1/8, plus the next interval, which is 2 times f of 2/8, plus 2 times the next one, which is f of 3/8, and then this is plus f of the last one, which is 1/2. And therefore, there is the start of our formula. So that means we're going to have 1/8 divided by 2 is the same thing as 1 over 2 times 8, which is 16. And then we want to find f of 0, which is the sine of 0 squared, plus 2 times the sine of 1/8 squared, plus 2 times the sine of 2/8 squared, or 1/4 squared, plus 2 times the sine of 3/8 squared, plus the sine of 1/2 squared. Okay, now before we calculate this, we want to make sure that we square each result of x before we put it in our calculator. So we have 1/16 times the sine of 0 plus 2 times the sine of 1/8 squared, which is 1 over 64, plus 2 times the sine of 1/4 squared, which is 1 over 16, plus 2 times the sine of 3/8 squared, which is 9 over 64, plus the sine of 1/2 squared, which is 1/4. Okay, so now we want to round this to 6 decimal places. So let's go ahead and put this in our calculator. So we want to be careful of parentheses. So we have 1 over 16 and then we're going to multiply that by the sine of 0 plus 2 times the sine of 1 over 64 plus 2 times the sine of 1 over 16 plus, and let me go ahead and insert this multiplication. So if you want to insert, second insert, put the multiplication there, and then this is plus 2 times the sine of 9 divided by 64, and then plus the sine of 1 divided by 4, and then close the parentheses, and there is our result. So we're going to round that to 6 decimal places. So we have 0.042743. And so that is the estimation for the trapezoidal rule. Okay, now we want us to do the midpoint rule. Okay, so if we want to find the midpoint, okay, before we do that, we know that we want to be able to use the rule of midpoint rule, which is delta x times f of the first midpoint plus f of the second midpoint, and so on. So to do that, let's go ahead and write that out. We have m subscript 4, and we know that delta x is 1/8. And so we're going to multiply that by f of that first midpoint. Well, over here we can see what the midpoint is. So what would the midpoints be? Well, the midpoints are going to be the middle here. Okay, so what are the midpoints? Well, if we take 0 and then plus 1/8 and divide that by 2, well, that becomes 1/16. Okay, if we take 2/8 and add 1/8 and then divide that by 2, then we're going to get 3/16. If we take 2/8 and divide that by 3/8, add 3/8 and then divide that by 2, well, that's going to be 5/16. And then 3/8 plus 4/8 divided by 2 is going to give us 7/16. And again, we are now using the midpoint. So there is our first one, there's our second one, there's our third one, and there is our fourth one. So we have f of 1/16. Now let's go ahead and then just complete this. So that's going to be plus f of the next one, plus f of the next midpoint, and plus f of the last midpoint. So again, we saw what the midpoints are. So we have f of 1/16, f of 3/16, f of 5/16, and then f of 7/16, because again we are using the midpoint here. So now we're going to go ahead and put this into our function. So we have 1/8 times the sine of 1 over 16 squared plus the sine of 3 over 16 squared plus the sine of 5 over 16 squared plus the sine of 7 over 16 squared. Okay, now again, before we put this in our calculator, we need to square our values of x. So when we square 1/16, That gives us 1 over 256 plus the sine of the square of 3 over 16, which is 9 over 256, plus the sine of the square of 5 over 16, which is 25 over 256, plus the sine of the square of 7 over 16, which is 49 over 256. So now let's go ahead and put this in our calculator. So remember, you got to be careful of your parentheses and don't add extra parentheses. So you have 1 divided by 8, which is delta x, times the sine of 1 over 256 plus the sine of 9 over 256 plus the sine of 25 divided by 256, and then plus the sine of 49 divided by 256, and then close out the parentheses, and then we get 0.040,849, and we round it to 6 decimal places, so that's going to give us 0.04085 as our midpoint approximation. Okay, so now we're going to go to the Simpson's rule. Okay, so what do we know about the Simpson's rule? Well, the Simpson's rule is the following. We know that the Simpson's rule is taking delta x and then divide it by 3, and then it's going to be f times the first subinterval plus 4 times the next subinterval of x plus 2 times the next subinterval of x. So let's go ahead and do that. So we're going to look for s subscript 4. We know that this is going to be delta x, which is 1/8 divided by 3. Okay, and then it's going to be f of 0, which is the first point, right? And then the next one is going to be very similar to these values up here because we have 1/8, 2/8, 3/8, and 4/8, which is 1/2. But remember what we're multiplying it by. So we know it's going to be 4 times f of 1/8 plus 2 times f of 2/8 plus 4 times f of 3/8 plus f of the last upper bound, which is 1/2. Okay, so that means now we have 1/8 divided by 3, which then becomes 1 over 8 times 3, which is 24. This becomes the sine of 0 squared plus 4 times the sine of 1/8 squared plus 2 times the sine of 2/8, which is the same thing as 1/4 squared, plus 4 times the sine of 3/8 squared plus the sine of 1/2 squared. Okay, now again, squaring the numbers of x before you put it in your calculator. So we have 1 over 24 times the sine of 0 plus 4 times the sine of 1 over 64 plus 2 times the sine of 1 over 16 plus 4 times the sine of 9 over 64 plus the sine of 1/4. Okay, so let's figure out what that approximation is. So let's go ahead and do that. So we have 1 divided by 24 times the sine of 0 plus 4 times the sine of 1 over 64 plus 2 times the sine of 1 over 16 plus 4 times the sine of 9 over 64 plus the sine of 1/4. And there is our result. And now what we want to do is round that to 6 decimal places. So we have 0.0414. So 0.41478. And there is the approximation for the Simpson's rule.